Hi there, my name is Lars Sorensen and we're here at CVC 2019 in Las Vegas. We're creating these short video bites for you to just get a hint of the exciting stuff that's going on here. We have so many researchers that came to our conference from all these different angles. It all concerns computer vision, but you can approach this obviously from a lot of different angles. In this next interview, we're going to dive into deep learning concerning facial recognition. I have a guest with us. We're glad we could steal him from the conference to just have some of his time. Dr. Marius Cordea from Majestic, a research scientist there. First off, to just hear a little bit about your experiences, how you're experiencing our conference so far. You're liking it?
Yes, I saw there were like a few papers on facial recognition, which is mainly my field, and my field is in biometrics research. And we just had our presentation and we had some positive feedback.
Good. Obviously, we have, like I said in the introduction, so many different research fields here.
Topics.
And so is it interesting for you also the other presentations? Are you learning something?
Yes, you can always learn something, and I was mostly interested now on the convolutional neural networks that I apply to the facial recognition problems and image recognition problems. So it's such a booming field for the past few years.
That's it.
And working on facial recognition, it's very important for the past few years with the booming of AI.
Yeah.
Because there's more and more raising concerns about privacy, so we need a very accurate, close to flawless face recognition algorithm.
Yeah.
To,
I can imagine this is, I will dive into the research that you presented here. This is also where the challenges lie, because close to flawless and keeping in mind privacy, I understand all those concerns, and I'm sure you do as well.
Yeah.
So do you feel that you really have to like work around it? Does it feel like a limiter or a handicap almost?
Not sure I understand the question. Like, it's like
well, I can because so many people are concerning that I can understand that maybe sometimes it's a trouble to get the right data or to get permission.
It's, people, I saw more and more people are criticizing, for example, the issue with Amazon, like confusing people, but people are confusing the problems of face recognition with gender detection or recognition, which are two different problems. And they don't know that facial recognition exists for so many years. I've been working since 2002, and it's widely used in border clearance by the governments for security, airport security, and surveillance. And used the right way, obviously we need that. And doesn't mean that if you match, you have a wrong match, like in a whitelist, for example, of wanted people. If you match a person wrongfully, just because probably you set the threshold too low, doesn't mean that automatically you're gonna
go to jail.
Exactly, go to jail.
Yeah.
There is always a human agent that takes the final decision.
Yeah.
Like you have the matching in an identification scenario when you match against, let's say, 100 persons, and it's always an officer looking at that list and say it's a problem or not a problem.
Yeah.
So I don't see such a big problem.
And it's maybe also, it's a cultural thing in that we're still getting used to that technology is helping us in this way. I guess you're saying you're working for so long, like since 2002. Lots have changed in how we look at it, I guess now. Yeah.
Yes, because with as I said, with the booming of artificial intelligence and more algorithms, and there is more and more need for privacy, and people are concerned about the invasion of robots and taking over everything. And I guess facial recognition comes a part of all these phenomena, so that's why. But there was never a problem until
That's
now. So
This specific problem that you were addressing in the research, could you explain a little bit to us what it is that you dived into and what it is that you found? And I understand we only have limited time here, but maybe to just give an idea.
yes, we put a lot of research on this latest facial recognition, and we came up with an algorithm that can be used not only for facial recognition but for other classification problems. So the main idea is to use knowledge-based information to inject in the neural network to help the training. Because normally the training discards like bad samples or difficult samples, so to speak. Like in the face recognition, for example, the rotated faces, age difference, light conditions, so forth. Those were discarded and not taken in consideration. So just by using some knowledge-based information and have some supervisory signals helping the network to do better, we include those samples, and we proved we plan to use to participate in some domain facial recognition challenges. I think we can do pretty well for the facial recognition at least.
And I guess that's a very interesting finding. And and would you have like an explanation why we eliminated those difficult elements like the turned faces and stuff? Because it sounds to me like if you compare it to how we humans learn, we get everything on our plate. If we try something new, we go wrong, we fail, and we need this to have a good learning process. And then I heard you now create this exactly for the system as well.
It's like you can have the intuition. For example, if you don't remember a movie or something, you know, it's. You always think, oh, that actor played in that movie, so you need the many cues. That cues help you finally, hopefully, to get...
Even the wrong cues help.
Yeah, sometimes, by association. And I was thinking intuitively to use this information like cues that are known for the facial recognition, because data sets are coming labeled nowadays, or you can do detection of the pose, of the age, and so forth, or the quality of the image. So if you use that label data and include in the training process, you can get a much better model.
That's awesome to hear. And then just to understand where we are right now, because you developed this algorithm now, and it comes to be in a different way, so it's much more enriched. Then it could be my suggestion, well, the industry must be waiting for this. Companies must be in line to be ready to adopt this in their existing systems.
Actually, there was lots of research done in the past years with the latest artificial intelligence, with the NVIDIA GPUs and the software, and you can use like millions and millions of pictures to do better and better algorithms. So I would say, obviously, we are not alone in this field. We are not pioneers. What we're trying to do is just to come up with algorithms to bring next level of performance, like closer to perfection. Of course, performance depends on where you train your database. Like you might train in a very easy database, as they were starting the facial recognition evaluations in label faces in the wild, and that became quickly saturated because the protocol was just comparing like few images against few images. Yeah. So anyhow, like now they have like more and more difficult data sets, and they saw that algorithms that claim like 99.92 performance in this data set, they were doing poorly in the other data set. So a good facial recognition algorithm should perform everywhere. In the wild data sets, in control environment images data sets, and that we intend to do, actually, to participate in those facial recognition challenges.
I want to thank you so much for being here with us and explaining, and I understand only in a short time, the very elaborate work that you guys do over at Majestic. So thank you so much for that, Dr. Marius Cordea. If you've liked this video, check out all our other videos. And if you just hit the subscribe button, we can even bring them to you much easier. Consider being with us for one of our conferences, and I hope to see you in the next video. Thank you for watching.